Chem students, can you see me? This video is going to be on the difference between just classification of matter. Okay, classification of matter. So matter is anything that has mass, takes up space. This pencil, me, computer, coffee cup. Air has mass, takes up space. You can put air in tires, put air in a balloon, it takes up space. It's made out of atoms. So matter is always made out of atoms. Okay, so atoms have space or have mass and they take up space. Not everything is matter. For example, light. You can't shine light into a balloon and have it get bigger. Like radio waves, UV radiation, infrared, okay, those things, cosmic waves, microwaves, those things are all forms of radiation that do not have any matter. Like you don't feel a piece of light hit you, okay, whereas you can feel air hit you because it's made out of matter, it's made out of atoms. So matter can be classified as either a pure substance or a mixture of pure substances. So a mixture will have multiple pure substances in it, mixed together. Pure substances you cannot split apart. So these cannot be split. So pure substances are either elements off the periodic table. So for example, like, copper or iron or aluminum or boron. So those are all elements. You can't split them apart without a nuclear reaction. Some of these are diatomic. For some reason, they occur in pairs like hydrogen, oxygen, but they're still pure substances. Okay, so any element of the periodic table is a pure substance. You cannot break it apart. Compounds are also considered pure substances. You probably don't know a lot of them, but NaCl, H2O. So these can be broken apart, but not physically. Like I can't physically take a piece of salt, NaCl, and break it apart into Na and Cl. I can't take some water molecules and just go, oh, here's the oxygens, here's the hydrogens. I have to do a chemical reaction to break those apart. So they're considered pure substances that cannot be split without a chemical reaction. There are lots and lots of compounds. You probably can't name a lot right now. Mixtures will be a mixture of these two things. So maybe you could have a mixture of elements or a mixture of compounds. So I could have like pizza would be a mixture. It's a very heterogeneous mixture, meaning it's not the same all the way throughout. So heterogeneous means you can see differences in it. My coffee is a mixture, pretty homogeneous mixture. It looks the same throughout. Okay, and it's a mixture of, right now it's got a little bit of actual coffee. Some people might put sugar in it. Maybe they have creamer in it and water. Okay, but it's a mixture of several things. So again, a mixture, if it's heterogeneous, it'd be like oil and water, pizza, something like that. A homogeneous mixture would be like pop. Air is a mixture. Air is made out of hydrogen gas, nitrogen gas, oxygen gas, carbon dioxide gas. It looks the same throughout though. You don't see the oxygen molecules over here, the carbon dioxide's over here. So again, mixtures will have either multiple compounds or multiple elements mixed together, not chemically combined, or it could be a mixture of compounds and elements mixed together. These you can separate. Okay? I can separate the oil from the water. Pizza, I can separate the pepperoni from the dough, the sauce from there. Okay? Pop, I could evaporate the water off and be left with the sugar, okay, without doing a chemical reaction. So you can separate mixtures without a chemical reaction. Compounds take a chemical reaction to split apart. Let me change screens here. Not something you have, but so I say identify the following diagram: element, compound, or mixture. Well, these are atoms, okay, and they look like they're the same atoms. So maybe it is two hydrogens, two hydrogens, two hydrogens, two hydrogens. So this is only hydrogen atoms. Okay, this is an element. Okay, it's a diatomic element, meaning two atoms together, but it's all the same thing. Okay, it's not two different things, so it's not a mixture. So that would be just an element. Okay, since it's the same two atoms. This is also an element. Maybe it's iron, 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 iron. Okay, it's the same element, same atoms, all the same atoms. So it'd be an element, a pure substance. Okay, we cannot split it apart. This would be like water. It'd be like water. So maybe these are oxygen atoms. These are hydrogens. Looks like Mickey Mouse. Oxygen, hydrogens. Okay, so this is a molecule of water. A molecule of water. There's 4 molecules of water in the diagram. There's 3 atoms in each one. So there's a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 12 atoms in this. But water is a pure substance. Okay, it's not a mixture of two pure substances. It's not a mixture of hydrogen and oxygen. It's a pure substance. The hydrogen and oxygens are combined. To split them apart would take a chemical reaction. So that is a compound, which is a pure substance. Water is a compound, which is a pure substance. This looks like we have a diatomic element such as hydrogen. So maybe this is hydrogen with hydrogen, but it's the same thing. Hydrogen, 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 hydrogen. Maybe these are some other element like iron. Iron, iron. So this is a mixture, and it's a mixture of elements. I can't tell you if it would be homogeneous or heterogeneous because I can't see it to see if it's all the same throughout, but it's a mixture of elements. I could separate the hydrogens from the irons very easily. Okay, they'd be two different things. This is an atom or an element. This is a diatomic atom. So it's two atoms together, or diatomic element, two atoms together. Okay, and again, those are combined. I can't split those apart. So that is a mixture of two different elements. Same thing, mixture of two different elements. So this is some element. Maybe it's helium. Maybe this is argon. Okay, so it's a mixture of two different elements. So it is a mixture, not a pure substance, a mixture. I could separate those two things without a chemical reaction. These are combined, okay, they're connected, so that is a compound. So this might be like carbon and oxygen. Okay, so maybe it's carbon, oxygen, carbon, oxygen, carbon, oxygen, carbon, oxygen, carbon, oxygen. So this is 1, 2, 3, 4, that's 5 molecules. Okay, 5 molecules, but it is just a compound, so it's a pure substance. I can't break apart these atoms, they're chemically combined. Mixture, it's a mixture of elements, Element, compound, element, compound. Notice this element is not connected to this compound. Okay, these are chemically combined, so they are bonded together. Can't break these apart, but I could separate out the red elements from these compounds. So this is a mixture of elements and compounds, but it is a mixture. Can't tell if it's homogeneous, heterogeneous in that case. That's all we got for there. Take care. Have a good day.